Edexcel Decision 1, Linear Programming 2, Formulation of the Simplex Method, Introducing Slack Variables. So many linear programming problems that you come across will be in the standard form shown below. So in this problem we want to maximize 5x plus 3y minus 8z. So there will always be an objective function and it will always be maximized. And this is subject to these three constraints. And these constraints will always be inequalities of the form less than or equal to some constant, and the constant will always be positive. And all the variables are non-negative. And it's these trivial constraints that are often left out. So we're going to look at an example to show how we deal with turning the inequality into an equality. So we have a 12-meter roll of cloth and we want to make dresses and skirts. A dress needs 3 meters and a skirt needs 2 meters of cloth. So we're going to let x be the number of dresses and we're going to let y be the number of skirts. So our inequality will become 3x plus 2y is less than or equal to 12, not forgetting that x must be greater than or equal to 0 and y must also be greater than or equal to 0. So we're going to look at some possible scenarios we could have that would fit this inequality. So here's my 12-meter roll of cloth, and we could make 2 dresses and 1 skirt. So 2 dresses would be 6 meters and 1 skirt would be 2 meters, which means I would have 4 meters left over. And this 4 meters is known as the slack. So we could also have 2 dresses, which takes up 6 meters, 2 skirts, which takes up 4 meters, and then we're left with 2 meters, which again is known as the slack. So the amount of leftover, also known as slack, varies, but it's important to note that it must always be greater than or equal to 0. So in order to deal with this, we're going to introduce a new variable s. So that our inequality 3x plus 2y is less than or equal to 12 becomes the equality 3x plus 2y plus s equals 12. Not forgetting that x must be greater than or equal to 0, y must be greater than or equal to 0, and now s must also be defined as greater than or equal to 0. So for the LP problem we've looked at before, we need 3 slack variables to deal with the 3 constraints, S1, S2 and S3. So we want to maximize 5x plus 3y minus 8z according to the 3 constraints seen here. Now in order to solve this algebraically, we need to turn these 3 inequalities into equations. So the first one will be x minus z plus s1 will equal 1. The second will be x plus y plus s2 will equal 2. And the third one will be 3x plus 2y minus 4z plus s3 equals to 6. We need to make sure we introduce the trivial inequalities s1 greater than 0, s2 greater than or equal to 0, and s3 greater than or equal to 0. This form is sometimes called the augmented form. And we will need to do this every time we wish to apply the simplex method. In the next section we will look at how to apply the simplex method. So this concludes the section on formulation of the simplex method.